Let's find the current through the vertical 2-ohm resistor using the node voltage method. We have two parallel branches. The left has an 18-volt source and a 2-ohm resistor that has a vertical 2-ohm resistor connects the branches. We need to find the current I through it. Let's discuss the steps for solving this using Kirchhoff's current law. Step 1. Identify the unknown node and current. This is Va and the current I through this resistor. Step 2. Apply KCL. The current is entering equal the currents leaving. For the node voltage method, we apply Kirchhoff's current law. The sum of currents entering the node is equal to the sum of currents leaving the node. Therefore, the equation becomes I1 equals I2 plus I3. I1 equals I2 plus I3. Now, according to Ohm's law, V equals I times R. Therefore, I equals V over R. We will apply Ohm's law. Let's assume VA to be smaller than 18 volts and greater than 12 volts. So we write the equation as I1 equals 18 minus VA, sim over 2. I2 equals VA over 2, and I3 equals VA minus 12 all over 2. This lets us solve for the currents in the circuit. Let's substitute the equations from Ohm's law into the KCL equation. From Ohm's law, we have I1 equals 18 minus VA over 2, and I3 is VA minus 12 over 2. Now substitute these into KCL. I1 equals I2 plus I3. This gives us 18 minus VA over 2 equals VA over 2 plus VA minus 12 over 2. Okay, let's solve this equation. We have 18 minus VA equals VA plus VA minus 12. First, let's combine the VA terms on the right. So we get 18 minus VA equals 2 VA minus 12. Adding VA to both sides gives us 30 equals 3 VA. And finally, VA equals 10 volts. So the required current is 5 amps. We got this by dividing the voltage by 2. This is our basic formula for this step. In our example, we divided 10 by 2. This gives us the 5 amps we need. That's step 5. The final answer is 5 amps. We calculated the current through this vertical 2-ohm resistor, so I equals 5 amps. Let's learn the node voltage method. First, apply KCL and use Ohm's law. Next, solve for the node voltages. Finally, find the required current.
The adventure isn't over yet. Subscribe to MindSpark Tunes for more amazing stories, history, and learning adventures. See you next time.